Hello, hello. 你好，你好。Get started in about 30 seconds to 1 minute, so get settled in. Alright, how are we doing? You guys doing okay? Hello, hello. Yeah, so today is going to be, I think this week's lesson is going to be a little bit easier, to be honest. But because we have a test, right, on Friday, remember that? So you're gonna look at basically a little bit fewer homework questions, and because you have a test on Friday, so I'm gonna leave you some time for that. Okay. All right. So let's take a look at this. So today we're going to talk about 3D figures. So we're going to explore three-dimensional figures and their characteristics. Okay, we are this is the 6, right? Great. All right. So before we talk about, looks like the stream kbps is not ideal yet, but I think it's catching up slowly. But I mean, it's not 100%, but it's not terrible either, right? All right, so let's take a look. So this is a typical three-dimensional figure we have, and sometimes we could have flat or curved surface. It depends on what you have, but that doesn't matter. What we're looking at today is mainly focused on a special type called polyhedron. What does the word polyhedron remind you of? You can polygon. Thank you. Uh-oh. Lagging a little bit. On with internet every time around this time. And it's only afternoon, and it's all only Wednesday usually. It's quite annoying. Oh, we're back. Oh. Okay. So missing Emily. So Emily, if you're watching or you're, send me an email or I don't know, I don't see your comments. Let me know if you're well. I think the rest of you I have seen. Yeah. Yep. Alright. Okay, looks like we're back in good terms. Yeah. It's always like this little spike. It's now all good, I think. Alright, so anyway, we're talking about exploring three-dimensional figures today. And there are several things we can look at. Face, edge, and vertex. Face is surface, right? These planes. And wait, what? Vertex and edge. Okay, so polyhedron is basically a three-dimensional polygon. Okay, it's a 3D solid, not sold, solid formed by polygons. Okay, formed by polygons. Oh, hi, Emily. All right, got you. Okay. Again. I am quite upset. I think it's slowly building back up. Slowly. I don't know what this is, to be honest. Slowly climbing back up. Slowly. I think it's going to be good for now. So we'll be quick, okay? It's not a lot of things to talk about, but we'll be quick. So typically there are two main types of polyhedron we're talking about today. One is called prism, and one is called pyramid. Okay, prism has two bases. They're congruent. If your triangles are bases, then you're called triangular prism. If you are rectangles, then you're called rectangular prism. Pentagonal means pentagon, right? So what you're looking at right now is really, you need to have two bases and they have to be congruent. Okay, they don't have to come upright like this, like you can be slanted, you're still called prism. But the idea is that your top and bottom needs to be the same base. Okay, it has to be congruent. Okay? Alright. So that's the case. Then let's look at this. This is called a cylinder. Keep in mind that this is basically a prism, but the base is circles. Because it's curved and circles aren't polygons, so we don't call this a polyhedron. It's not a polyhedron, but alright, so then the next thing is called pyramid. Pyramid is like a prism, but you only have one base. The other one converges to a point. okay? And that point is an extra vertex. Similar with cone, but with circular. And the naming is very similar as well. As you can see, the base determines what name it gets. Okay, the base shape determine what kind of name it gets, like triangular pyramid, rectangular pyramid, pentagonal pyramid, hexagonal pyramid. Okay, so before we continue, I want to mention one thing about face, edge, and vertex. Can you count all at once? Okay, just tell me how many F is, how many V is, how many E is. Okay, how many number of faces, how many number of vertex, what's the number of edges? Okay, tell me about that. So there's a famous person that studies this. Type in the comments once you count them all. Six, 8, 12. Like that. Okay. So some of you might wonder, well, what is the relationship we can look at based on this? Well, let me tell you about this is that there's a famous guy called Euler. And it's called his formula. The name here is called Euler, like the way it's pronounced. If you call it Euler, then people know that you don't really know math, right? Okay, his name is Euler. I think I'm lagging a little bit, but I think I'm still getting through it. Name is Euler, okay? Euler, and the formula goes like this. Number of faces plus number of vertices minus number of edges for any polyhedron is always 2. Okay, it's always 2. FPS is dropping a little bit. Okay. Hopefully it gets better soon. It's very streaky. Sometimes it's good, sometimes bad. Okay. So if you look at what they have right now 8 plus 8, 6 plus 8 minus 12 is 2, right? And this is true for any polyhedron, okay? Which is basically what you're looking at, okay? So let's look down here. So classify the figures, all right? And they say name the vertices, but let's not name it, okay? Let's count. Count how many, and instead of looking at bases, let's look at faces, okay? Number of faces. So first of all, let's identify what is this? What is this polyhedron's name? What is the polyhedron? What kind of polyhedron is this? So you have to look at the base first, right? What shape is the base? Pyramid is correct. Okay. This is a pentagon, right? Pentagon. So pentagonal, and it's a pyramid because it converges. So we call this a pentagonal pyramid. Pyramid, right? So, can you name, once again, faces, vertices, edges, how many each? Right, which was F plus V minus E equals 2, right? Is this true? Take a look. So 6 plus 6 minus 10, that's 2, right? All right, can you do the same for the one on the right? Can you do the same? Triangular prism is correct. How do I know that? Well, look. You want to look for the two bases that are triangles, not the base here that looks like a base, but just because it looks like a bottom. Okay? What you're doing is make sure you're looking at two identical bases. Some of you might think that this is a rectangular prism, right? Rectangular prism, however, has to converge to one point, right? Has to converge to one point. Here, they have 2 points. That means it's not a rectangular prism. And then you look at the other side, you kind of have to tilt it over to see that, oh, it's actually a prism. But by definition of prism, it doesn't say it has to be upright like this. It can be sideways like this one. Okay? So this is a triangular prism. Okay. Once again, F, E. 5, 9 is 2, right? So that would work. Okay? Is it better now? It's not that good. 5, 6, 9. Is that what you get? Okay, guys, it's almost over. Promise. Okay. All right. Alright. So, if that's okay, let's flip it over. So, with these kind of things, it's basically what happens after three-dimensional fold. Okay, so that means, for example, you can identify what kind of polyhedron or shape based on what they give you. For example, this one is, I don't know if you're familiar with this. This is a typical, like kind of like a box, right? Because it's a cube, isn't it? Like you just fold it up, and then you'll get a cube. Like when you fold it up, it will look like this, right? After you fold it up. So a cube is obviously you can call it a rectangular prism as well. So it's a cube, but if you want to call it a prism, it's going to be a rectangular prism. Is it a polyhedron? Yes, it is. Okay, it is a polyhedron. Okay. What is this called? What? Oh, lagging again. Is triangular pyramid a type of polyhedron? A type of polyhedron? Hopefully we get back up soon. It is, right? Yeah. I don't know how to do this like this. We're almost done though. Hopefully it start growing back up soon. But it's around like 200 to 36. We're used to being at 3,000. So that's why it's lagging and blurry, which is kind of a shame. Hard. But we're back at 36 again. So are you still there? Okay. Oh my goodness. I don't know how to fix this though. So both of these are not polygons, so you can't. All right, so if worst comes to worst, I'll have to So if you look at the last part, I'm going to get this over with, and then I'll give you a link later after I'm done with this, and then you can look at your what you missed, because I'm not sure which part is lagged, which part is not lagged, so we'll just look at it. You can look at what you're missing later, okay? So this is cross section is what you cut, okay? So if you cut this, you'll get a point, right? Because it's not from the tip. If you cut like right in the middle of a cone, then you should get a triangle like this, right there. If you cut in the middle like this, then you should get a pentagon. Okay, these are called cross sections. You know, every time when I'm about to give up, it gets a little better. I think it's a life lesson. Alright. So, the last part I want to talk about is, like, how does, if I have a flag, right, a rectangular flag like this, or I have a triangular flag like this, what happens if I rotate them really, really fast? What kind of solid would it form if I rotate them really, really fast? What would happen? I rotate them really, really fast. The two flags. What will happen? What kind of shape would it form? Okay. Wow, it's now all the way to full capacity. I think it's a sign, guys. I think it's a sign. What kind of polygon? Well, if I spin it, doesn't it go in a circle? So what will it look like? So first of all, when I spin it, this part will go over here and go backwards and over again, right? What will it look like? Clara said it will be a cylinder and a cone. So it will rotate over, right? Like that. Right? And if you spin it fast enough, then your optical illusion should see a cylinder being formed. Okay. That's what it should look like. And similarly, here you should be able to form a cone. Oops. Like a little more extended, I guess. Like this, right? And you should be able to see a cone forming. Right? As you spin this. Okay. So you should be able to see it formed as you go, or as you spin it. Okay? How are we doing? Is this making sense? All right, last part before we go, homework and test. Okay, both of them are big ideas. Time frame is slightly different. Homework is 11.4. Like I said, it's a relatively short homework. This is due Sunday, May 10th. And the test is chapter 10. This is on Friday, and it's open. The assignment's open at 7:20 a.m. I'll put the date too. It's May 8th. 7:20 all the way to 11:59 p.m., which is the whole day, but it probably takes less than an hour to finish. But that is what I'm giving you. It's open notes. You can use any part of your notes. You can use any part of your book. Okay, just finish the assignment. Make sure you do this one in time. I can't reopen this once the time has passed. Okay, so find some time that day to do it. Okay, it shouldn't take you long, but you should take some time to do it. Okay, And at last, I know it's been laggy. If there's any unclear part that you didn't get down, I'm putting in the morning session video. So just in case that you're missing some parts of notes, but you're not sure, it's the exact same thing in the morning, but without the lag. I'm glad you guys stick through, but it's been a pain, but I'm glad you guys stick with it. Okay. Yeah, the test is right here. So I don't know if it's multiple choice. I don't think it is. It's like homework. It's kind of like homework questions. Think about it like homework questions. Okay. Test is chapter 10. Okay. Yeah. You can't check. I don't know if you can check, but you can like make sure you do it right until the end, so you can go back and forth. Yeah. You guys have a point. Yeah. Well, any other questions about I'm not sure if you should like this vid. You should go like the other vid I send out in the link. I don't know why I always lag at exactly when. Like right now, it's so smooth. The test, if you get a question wrong, you can go back and do it until you get no. So Cindy, it's like a normal test, but you have like a whole day to do it. I don't think you can check, like actually click check answer, and it will tell you if it's right or not. Like you have to like you check like how you check things on the test, basically. You recheck your answer and stuff. I don't think it allows you to, it doesn't give you the right answer until you click submit, I think. At least that's how I designed it. But when you actually do it, hopefully that's what it does. Okay? Does that answer your question? Just think about this as a typical test, but you have the ability to do it for the whole day and open notes. But the difficulty is about the same. Okay? Any other things? Well, thanks for coming. Goodbye.